Okay. Question 10. The correct options about entropy is slash R for the reaction this. If dE cell by dt is equal to R by F, then the entropy change of the reaction is R. Okay, I think NFE. Okay, here's the thing. We have delta G is equal to minus NFE cell. So d of delta G by dt is equal to minus NF dE cell by dt. So delta H minus T delta S. So this is actually equal to minus delta S minus NF dE cell by dt. Minus minus cancel. dE by dt is equal to delta S by NF. And N is the number of electrons exchanged in the reaction. So and N is equal to 2, right? So delta S is actually equal to 2R. Then the entropy change of the reaction is R. No, that's wrong. It should be 2R, I think. The cell reaction, this is an entropy driven process. Well, the enthalpy change is 0, right? Delta H is equal to 0. Is it? Okay, see, C we can agree with, right? Delta S is going to be greater than 0 for racemization because it like becomes random. Delta S is greater than 0 for this. Yeah, this is why the reaction happens. The chelation effect actually increases the entropy. So CD is correct. Now about B. So we have, what do you call, the cell constant according to Nernst equation is equal to minus RT by NF ln 1 bar into 1 bar 0.01 mole by 0.1 into 1 bar. So this whole quantity is negative, so the entire quantity is positive. So E cell is positive, dE cell by dt is also equal to positive because this thing is equal to E is equal to RT by NF into some constant C. dE by dt is equal to some positive constant RC by NF. So dE by dt is directly proportional to delta S with no sign change, as we found out here. So I think BCD is the answer. Question 10 is BCD, yeah. And then next question, the compounds which react with NH3 to give boron nitride. B2H6 is correct. Does boron react with NH3? No, I think B2O3 gives the reaction. HbF4 plus NH3 does not actually give anything. I think BF3... No, I think it's just BC. 11 is BC. Yeah, it is. B2O3 is the answer. Again, that's just reaction. But then again, I just guessed because I don't remember chemistry right much. I just know like physical chemistry, which is very this based, like logic based. It's like physics again. Question 12, the correct option related. I mean, what am I supposed to say about this? Coke C converts CO2 to CO. Is this correct? Does it? I don't know. See, honestly, I don't know. I'm going to leave this question. But yeah, that's question 10 and question 11 done. Actually, let's just continue. The video isn't long enough. I'll fit one more question in. Okay, this is again theory. Polymerization of chloroprene gives natural rubber. Is that correct? No, it's not. Is it? Polymerization of chloroprene gives natural rubber. No, it does not. How is that correct? Chloroprene is like something like this, right? This gives like some fake synthetic rubber. Um, that's not correct. So I think A is wrong for sure. Teflon is prepared by, tetrafluoroethene by heating. Yeah, B is correct. PVC or therm, I don't know about that. I don't know. Ethene at this and this in the presence of peroxide, it gives low density polythene, doesn't it? So the answer is BC. Question 14 is BC. Yeah. So A is wrong. It's not chloroprene. Natural rubber does not contain any chlorine at all. In fact, I think natural rubber is just like this. I forgot exactly, but then I don't remember, but like, yeah, natural rubber is not chloroprene. Oh, you left all four? How did you leave all four, anyways? Did you run? I think you ran out of time, maybe. Atom X occupies the FCC lattice, as well as alternate tetrahedral voids of the same lattice. The packing efficiency of the resultant solid is closest to. Okay, so we have a cube. FCC is face-centered cubic. So we have one atom here, one atom here, one atom here, one atom here. And then face-centered, one here, one here, one here, one at this center, one this center, one this center. Okay, and then we have them in the alternate tetrahedral voids as well. This one, this one, this one, and this one. So, if they occupy alternate tetrahedral voids, that would mean that in the cube, the distance from the center of the cube to one corner of the cube is wait, no, never mind, that's not how it works. That's not how it works. We need to find a better relation. They occupy tetrahedral voids, right? And it's face-centered cubic. Oh yeah, okay, that's how it works. The distance between the center of the corner, the center of some corner, I think this is the solution. The distance between center of this corner and the one which is occupying the tetrahedral void, the distance between two of them is equal to 1/4 of the distance between the diagonals. So root 3a by 4 is equal to 2r. This is the relation. And how many total atoms are there inside this? How many like atoms are packed? We have 8 corner atoms, which is equal to 8 into 1 by 8 per corner atom, which is equal to 1 effective atom. Effective. And now we have 6 faces, 6 face-centered atoms, so which is equal to 3 atoms. And then we have 4 alternate TV, so which is equal to 4 atoms. So we have 8 total atoms into 4 by 3 pi r cube volume per atom divided by a cube is the volume of the cube, which is, so r by a is equal to root 3 by 8. This thing whole cube is equal to 3 root 3 by 8 into 8 into 8. So we have 32 by 3, this thing, is 32 by 3 pi into r cube by a cube, which is equal to 3 root 3 by 8 into 8 into 8, 3 gone, 8, this is 2. So we have root 3 pi by 16 into 100 is the answer. Like they asked in percentage, right? So 4 4s are 4 25s are 25 into 1.73, which is root 3 into 3.14, this whole thing divided by 4. 12.5 by 2, 6.25. So we have 6.25 into 1.73 into 3.14. 6.25, 1.73, 3.14. So 6 threes are 18. 18 into 2 is approximately 35. Okay. 6.25 into 1.73 into 3.14. See, it's not going to be as low as 25 because we have 18 plus, which is something like 20 into 1.73. Yeah, I think B is the answer. Like, it's a rough calculation. If you calculate this, I'm sure you'll get 35, which I'm gonna do it on a calculator right now. 6.25, 1.73, 3.14. The answer is 33.95, so B is the answer. Question 15 is B. How much time over? 11 minutes. I'm gonna stop.